In Chapter 311, we're going to look at dividing fractions and mixed numbers. So we're going to think about some situations that involve division, and we're going to start by modeling those division types of situations. So for our first example, let's say we have 5 pizzas, and we have 8 people that we need to feed. So we want to know how much pizza does each person get. Right? So we're going to take those 5 pizzas and we're going to divide them into 8 groups. I have 8 people. I'm going to divide that into 8 groups and see how much lands in each group. So one way to accomplish that task would be to take each pizza and divide it, slice it up into 8 pieces, and then we'd say, okay, here's 1 piece for this guy, 1 piece for that guy, and we could make 8 piles from that, starting with that pizza, and then we would add 1 from each of these to each of those piles, and we would see that each person gets 5/8 of a pizza. So 5 divided by 8, 5 divided by 8, each person would get 5/8 of a pizza. Okay, so for this situation, let's say I have 2 cups of mozzarella cheese, and I'm going to use 1/3 of a cup for each pizza that I make. And I want to know how many pizzas can I make. So this is another type of division situation. I'm taking the total amount of 2 cups, but this time I'm not dividing it into a number of groups. I'm going to divide it into the size of group that I need. I need to see how many groups can I get of the size 1/3. So I'm taking my 2 cups and I'm going to divide it by the size of 1/3, and I want to see how many groups can I make of that size. Okay, so I've taken my 2 cups and I'm dividing it into sizes of 1/3, and I want to see how many groups of that 1/3 can I get. Oops, sorry about that. So you can see that I've got 1, 2, 3, 4, 5, 6. I was able to make 6 groups of 1/3 each. So 2 divided by 1/3 equals 6. I can get 6 groups of 1/3 each. Okay, here's another situation. Stuart has 5/8 cup of flour. He uses 1/2 cup for a batch of cookies. How many batches of cookies can Stuart make? So again, this is division. We're taking a total amount of 5/8. That's our total amount. And we need to divide that into sizes of 1/2 cup and see how many groups of 1/2 cup can we make, because it takes 1/2 cup for a batch of cookies. Okay, so we have an illustration of 5/8 of a cup, and we're going to take that entire cup and divide it into half, and we're going to see how many of this half size of a cup, 1/2 of a cup, how many can we make. So what we're going to do is we're going to take a few of these little pieces and move them over here so we can fill in that 1/2 of a cup. So if we take our 5/8 total and divide it into sizes of 1/2, we can see that we can get one size of 1/2, and then we have some leftovers. Well, what part of 1/2 is this that we have left over? Well, if we take our 1/2, we can see that it divides evenly into 4 sections of that leftover size. So that means this leftover size represents 1/4 of a 1/2 cup, which is 1/4 of our size. 1/2 cup is our size, 1/4 of that. So 5/8 divided by 1/2 leaves us with 1 group of the 1/2 and another quarter of that group of 1/2 size. 5/8 divided by 1/2 is actually 1 1/4. Stewart could make 1 1/4 batches of cookies. All right, now let's see what's happening mathematically when we look at the 3 situations that we modeled earlier. In the first situation, we have 5 pizzas divided by 8 people, and we said that meant that each person got 5/8 of a pizza. In the second example, we took 2 cups of mozzarella cheese and divided it by 1/3 to see how many groups of 1/3 we could get, and we found that we could get 6 groups. We could make 6 pizzas. And in the last example, we started with 5/8 cups, and we divided by 1/2 to see how many groups of 1/2 we could make. And we found that we could make 1 1/4 groups, or 1 1/4 batches of cookies. So what's happening mathematically to get these results? Well, if you remember, when we were studying integers, we said every subtraction problem could be rewritten as addition by adding its opposite. Okay, because addition was the inverse operation of subtraction. Well, multiplication is the inverse operation of division. So we're going to take every division problem and rewrite it as a multiplication problem. So the way that works is we take our beginning number. We don't ever change that. It's 5/1. We're going to rewrite it as a multiplication problem, but we don't take the opposite sign this time. We take the reciprocal of our fraction. We flip our fraction. So to turn any division problem to multiplication, you copy, change, and flip. Keep the first number and then multiply by the reciprocal. So you notice when we do that, we get 5 times 1 in the numerator and 1 times 8 in the denominator. That's how we got our 5/8. In our second example, if we always keep our starting number, so 2/1, we're going to rewrite this division as multiplying by the reciprocal. We're going to copy the first number, change to multiplication, flip the second number. We end up with 2 times 3 in the numerator, 1 times 1 in the denominator. That's 6/1. That's how we got our 6 for our answer, 6 pizzas. And then finally, we have 5/8. We're going to change to multiplication, and we're going to multiply by the reciprocal. So we have 5/8 times 2/1. And because we're multiplying fractions, we're going to look for that opportunity to simplify before we multiply. And we notice that 2 is a common factor between the 2 in the numerator and the 8 in the denominator. So we're going to divide by 2 to get 1. We're going to divide by 2 and be left with 4. So now we're looking at 5 times 1 over 4 times 1, which is 5/4. 5/4 then simplifies to 1 1/4. And that's how we got the answer of 1 1/4. All right, so when we want to divide fractions, remember we're going to copy, change, and flip. Copy your beginning number, change to multiplication, and take the reciprocal or flip the second number. Okay, so in this first example, 4/5 divided by 1/2, we're going to copy the 4/5, change to multiplication, and take the reciprocal of the second number, so flip, we get 2/1. And then 4 times 2 is 8, 5 times 1 is 5, so we have 8/5. But then we're going to rewrite that into a mixed number, which is 1 3/5. Okay, example number 2, 5/8 divided by 5/6. Copy the 5/8, change to multiplication, and flip the 6/5. Okay, we're going to do some simplifying before we multiply. 5 divided by 5 is 1, and 5 divided by 5 is 1. Now we also have a common factor between the 6 and the 8. We can divide by 2. So 6 divided by 2 is 3. 8 divided by 2 is 4. So when we're done simplifying, we have 3 times 1 in the numerator is 3. 4 times 1 in the denominator. Okay, and that's just 3/4. Example number 3 is a little bit different. How is example number 3 different? Yep, we've got mixed numbers. So before we start doing anything, we want to rewrite our mixed numbers as improper fractions. Okay, so 2 times 2 is 4. 4 plus 1 is 5. We have 5 halves. 1 3/4 can be rewritten into an improper fraction as well. 1 times 4 is 4. 4 plus 3 is 7. So we have 7/4. Now you want to copy, change, and flip. Don't try doing it at the beginning. You need to rewrite everything as an improper fraction first. So now let's copy, change, and flip. Our starting number is still 5 halves. That's our total, and we don't change that. So copy the 5 halves, change to multiplication, and now we're going to take the reciprocal of our second fraction. We're going to flip it, and we get 4/7. Okay, and now we take an opportunity to look for those ways to simplify. And we've got a 2 and a 4 in the denominator and the numerator. We're going to simplify those. 2 divided by 2 is 1, and 4 divided by 2 is 2. Okay, so now we're looking at 5 times 2 is 10, and 1 times 7 is 7. And 10/7 is improper, so we're going to rewrite that. 7 goes into 10 one whole time, with 3 of those 7s left over. All right, and the last example, 2 2/3 divided by 1 1/5. We're going to rewrite as improper fractions. So 2 2/3 is the same as 8/3. 1 1/5 is the same as 6/5. Now we copy, change, and flip. Our total amount is 8/3. Change to multiplication. Take the reciprocal of the second fraction. And we look for opportunities to simplify. There's a common factor of 2 between 8 and 6, so we're going to divide by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. So now we're looking at 4 times 5 is 20, and 3 times 3 is 9. And then we have an improper fraction. We want to rewrite it into a mixed number. 9 will go into 20 2 whole times. That would give me 18, which means I have 2 of those 9ths still left over, 2 2/9. All right, here's a couple problems for you to try. The first one is 2/3 divided by 1/5. The second one is 4 4/5 divided by 6/7. Remember, with your mixed numbers, you want to rewrite them as fractions first, and then you copy, change, and flip. And when you get to the multiplication step, always look for ways to simplify before you multiply. Look for your common factors in the numerator and the denominator.